Hi, welcome back. We would want to continue with our exercise of identifying lowest hanging fruits in paper 2. So the principle of lowest hanging fruits is about identifying those very easy marks that you can get in any given paper, because how a maths paper is structured is in such a way that approximately 30% of the paper is very easy marks that you can easily access without a lot of effort. You just need to practice and learn some basic things about maths. So you can get about 40 marks or more by just grabbing those lowest hanging fruits. Whenever you get to a question paper, I want you to look out for these keywords. Write down. Write down is something that must always trigger that this must be a lowest hanging fruit. These are easy marks. If you see the word determine is also another easy mark there. Then calculate. Usually when they say calculate, you are going to discover that those are very easy marks. Other key hints for these easy marks is if you look at a question paper or a question and you identify all those 1 mark or 2 mark questions, those are usually easy marks. And you must be able to identify the right formulas from your information sheet. That is also another source of easy marks. Then after identifying the right formula, it is very important to know how to substitute correctly. And when you're substituting, please make use of your brackets. The other thing in paper 2, especially when you're talking about geometry, know your theorems. It is very important to know your theorems because those are sources of easy marks. So in this session, this is part 2 of lowest hanging fruit for paper 2, because in part 1 we looked at data handling and trigonometry. So in this session, we are going to focus on the second part of paper 2, which is analytical and Euclidean geometry. And we are going to pay particular attention to November 2018 paper 2 question paper. So when you are doing geometry in paper 2, it is very important to know that there are some obvious questions that are going to come. Questions such as proving a theorem. There are 6 examinable proofs that are going to come. We know that they are going to come. So this is the first theorem, then this is another one, then the third one is this one, the fourth one is the turn chord, the proportionality theorem, as well as the similarity theorem. They are 6. This makes up the 6 examinable proofs, and if you know how to prove these, you are guaranteed of 5 to 6 marks in any paper 2 that comes. And if you practice every day, making sure that you practice a theorem, I promise you it will stick on your mind and you grab those marks easily. Now let's go to question 3 on our November 2018 paper. It was focusing on analytical geometry. So let's identify the easy marks there. 3.1.1 is a lowest hanging fruit there. 3.1.2 is another one. 3.3 is another lowest hanging fruit. I'm indicating 3.4 is another one. 3.5.2 is another one. As you can see, it's calculate, it's determine, it's calculate the gradient, calculate the size of theta. So those are easy marks. Let's see how are we going to grab those easy marks. So going to 3.1, you see 3.1.1, you see that it's asking you to find the gradient of Kn. Remember, gradient of a point, if you are given the coordinates Kn, we have got the coordinates of K, we have got coordinates for N. So you simply have to choose that formula from the information sheet, substitute correctly, and simplify. Okay, let's go to 3.1.2. 3.1.2 is saying calculate the size of theta, which is an angle of inclination of Kn. And we know that angle of inclination, you have to choose this formula. M is equal to tan theta, where M is the gradient of the line, and we have calculated it in 3.1.1. So you just need to substitute and simplify. Okay, going to 3.3, we see that it's asking for the equation of a straight line. And for you to find the equation of a straight line, you simply need two things, a point and gradient. And you can see that the gradient of LK is 1. It has been shown in 3.2. Okay, even if you failed to show it in 3.2, but you can still use it. And there is a point K which is negative 1, 2. So what you simply need to do is to choose any of the two formula to find the equation of a straight line from your information sheet. You either use this one or you use that one. Okay, you substitute and simplify. Okay, and make sure that you leave it in the form that they've stated. Even if you choose this form, if you simplify, it has to simplify and make y the subject of formula so that it looks like this. Going to 3.4. 3.4 is asking for the length of Kn. Remember, the coordinates of K and N are given, so you simply have to substitute in the distance formula, and you simplify correctly. Remember to use brackets when you substitute. It's very, very important. Okay, let's go to 3.5.2. 3.5.2, it requires you to analyze, because it's saying determine the coordinates of L. And the analysis that is here is not that difficult, because we are told that L, M, and K is a parallelogram. So this line is parallel to that line. LK is parallel to MN, and LM is parallel to Kn. So what I want you to know is that the relationship between point K and point N is that there is a transformation, there is movement. And that relationship that exists between K and N is the same relationship that exists between L and M. Now look at N. If you want to get to K from N, you go up, then you turn and you go to the left. This angle here must be 90 degrees. And if you can check, the upward movement is the Y movement. So from -1 to 2, how many units are those? It means you are adding 3 units from -1 to 2. And from here, if you move to the left, this left movement is the X movement. So from 1 to -1, how many units are those? You simply subtract 2 for you to move from 1 to -1. So the same movement that you see up here is the same movement that must happen down here. So let's see how it will happen from M to L. So you have to move up, then you turn to the left. And remember, moving up we said +3, moving to the left we said -2. So -5, so that gives us our y. -5 plus 3 will give us -2. And for our x, we simply say -3 minus 2, and it gives us -5. Therefore, coordinates of L will be -5 raised to -2. Okay, that is how you get that. That's an easy mark. Okay, so those are easy 3 marks. Okay, let's go to the next question. The next question is question 4. Question 4, let's identify the lowest hanging fruit. So 4.1 is low hanging fruit, write down. 4.2, calculate, is another low hanging fruit, write down, is another low hanging fruit. 4.3, 4.4 give a reason. It's just another lowest hanging fruit. And 4.5.2 is another low hanging fruit. So let's see how we are going to grab those low hanging fruits. So if you look at question 4.1, it's saying write down the coordinates of f, and f we know is the center of the small circle, and the center of the small circle we will get it using this equation, because this is the equation of the circle. And if you compare that equation to the one given on the information sheet, this one, if you compare these two equations, this one and that one, you see that f is actually equal to positive 3 s2 positive 1. All right, then those are easy 2 marks. Then let's go to 4.2. Calculate the length of fs. fs is this. It's the radius of the small circle, and we know the coordinates of f is that, the coordinates of s are given. So to find the distance between f and s, we simply use the distance formula. Okay, remember, let me put it here because I don't have space. 4.2 fs will be equal to the square root of x1, actually x2 minus x1 squared plus y2 minus y1 squared. So the square root of this is going to be your distance fs, which is the radius. Now going to 4.3, it's asking us to find the length of hg. In this case, we are not going to use the distance formula to find the length. We are going to use this information that we are given. We are given this ratio. This ratio is actually telling us that fh is k and hg is 2k, because the ratio is 1:2, which means now finding that fh, we don't know it, but what we know is fs, and we know that fs and fh are equal because they are radii, and therefore to find hg, it is twice fh, and fh is fs that we've calculated on 4.2. Okay, so let's move on. 4.3, give a reason why jh is equal to jk. So 4.4, the reason, you can see that these two are tangents from a common point outside the circle. So that is the reason. Okay, so let's go to the next question. The next question is 4.5.2. 4.5.2 is asking us to find the equation of the circle with center G in terms of m and n. Remember, the formula that you need to recall is this one, and this formula is, you just extract it from the information sheet because it's given, and you substitute it correctly using your center mn. Remember, m in this case is your a, n is your b, then your radius hg is the one that we have calculated previously. So it's a matter of you substituting, and that's it, you get your 1 mark. Now, okay, let's go to the next question. Our next question is question 8, and question 8 is a geometry question, Euclidean geometry. And some of you might have watched our video that we did before about the strategy that you can use to approach geometry riders. And to some of you who haven't watched that video, I'm encouraging you to go to the Excel Education YouTube channel. There is a video which we did on the strategy to approach geometry riders, which is talking about Dr. Cape Town. If you can master that, then geometry will be a walk in the park. So in this case, this question I can tell you that 8.1, 8.1.2, 8.1.3, and 8.1.4. Those are easy marks. They are low hanging fruits because it requires numerical values of angles. What I can tell you is 8.1.5 might be the one that requires you to think, but those four are very easy, and those are how many marks? 2, 4, 6, 7 marks that you can grab easily. So let's apply Dr. Cape Town to this question so that we see how many marks, how we can grab these lowest hanging fruits. Okay, so Dr. Cape Town is this. Dr. Cape Town. Okay, so let's look at D. So before you look at the questions, look at the diagram and the information and check if there is any diameter. And if there is any diameter, think about this theorem. So here you can see PN is a diameter. Therefore, this angle here is 90 degrees. Okay. After that, you check if there is any radius. So if you look, there is a radius OR. Okay, OR is a radius, and we also see that we can also see PO as a radius and ON as another radius. So one thing that we know about radii, they are all equal in length. So we can simply do this and show that these three lines are equal in length. Okay, for the fact that this PO is equal to ON and NP and RO are parallel lines, something is clicking on my mind, because now O becomes the midpoint of one side of a triangle and the R parallel lines. It takes me back to grade 10 where we talked about this theorem, the midpoint theorem. Therefore, if we have got this as the O as the midpoint and these two lines are parallel, it therefore means that these two lines are also equal. And because of that, you will see that this theorem will inform you that there is a right angle here. This angle here is 90 degrees because these two lines becomes perpendicular to each other. Okay, so let's talk about C. C is a cyclic quad. And if you look at our diagram, we don't see any cyclic quad yet. We don't see any cyclic quad yet. But also C can refer to chords. Are there any chords that are subtending some angles? And also a chord can interact with the tangent. That's your T here. So there's a tangent MT and there's a chord MN. So the angle here, 66 degrees, that is here, must be equal to the angle subtended by the same by this chord on the alternate segment. So this must also be 66 degrees. Okay, so we have touched T, we've touched C. Let's talk about P. P are parallel lines. They have helped us to see that the midpoint theorem applies, but also because these two lines are parallel, MP and RO, it therefore means that this angle here, O2, is corresponding to angle P. So this is also 66 degrees. Okay. Right. After applying Dr. Cape Town, you also have to check, is there anything that you can figure out? And I want us to consider triangle MPN, that big triangle. The other angle M2 is 90, angle P is 66, therefore angle N1 is 24 degrees. Remember, sum of angles of a triangle, they add up to 180. Okay, so after that, you can now look at the questions and extract the right answer and put the relevant reason. For example, angle P on 8.1.1, angle P is 66 degrees. On 8.1.2, angle M2 is 90 degrees. We have already found that one. So you need to write it down and write the right reason. Okay, angle N1 N1, we've calculated it. Remember, because of the sum of angles of a triangle, we found N1. Then angle O2. Angle O2 is already 66 degrees because it's corresponding angles. All right. So we've grabbed those 7 marks without any stress. Moving on, we go to question 8.2, which is talking about that interesting figure. And I can tell you that that 1 mark explaining that it's a low hanging fruit. Let's see how we're going to write it down. So, because ABCD is a rectangle, we know that opposite sides of a rectangle are parallel. So this is parallel to that, and that is parallel to that. So we are interested in talking about AB is parallel to GH. Remember GH, we are told that these two are parallel, so it's given. Then AB is parallel to CD, but CD can be produced to form FC. So we can say AB is parallel to FC, and the reason is opposite sides of a rectangle. Okay, so because of that, it therefore follows that FC is parallel to GH. Done. Then you get your 1 mark. Let's move on. Moving on, you see that there is question 9. Question 9 is asking you to prove a theorem. And remember, we talked about that and said those 6 theorems, know how to prove them. So here you just have to reproduce the theorem the way you've practiced it, and you get those 5 marks. 5 easy marks. Okay, let's go to 9.2. 9.2 is similar to 8.1, where you apply Dr. Cape Town, but we need to identify where are the lowest hanging fruits. The whole of 9.2.1, those are lowest hanging fruits, where we are naming and giving reasons. A, even on B, those are lowest hanging fruits. The other questions, they are easy to get, but not very easy. Remember, we are focusing on the lowest hanging fruits. So let's see how we are going to grab those 4 marks. So I want you to think about, looking at the diagram, think about this theorem. Angles subtended by the same arc or chord are equal. Angles in the same segment. So you can see ST is subtending this angle here. At the same time, is subtending this angle here. So you can see that angle B1 is also equal to X. Okay, think about this one again. This is a cyclic quad, and I want us to look at this cyclic quad. B, T, R, D, okay? And I want us to extend this to produce that line. So if you do that, that's a cyclic quad, and you can see that angle R1, this one, will be equal to angle B2, which is equal to Y, because these are angles opposite, and this is the exterior angle equal to opposite interior angle. Now, that means that naming and giving reasons for question A will be B1 is equal to X, and the reason is angles in the same segment. Then for question B, to show that the other angle that is required there is B2, which is equal to Y, and the reason is exterior angle of a cyclic quad equal to the opposite interior angle. All right, let's move on. Moving on, we get to question 10. So question 10, we need to identify the lowest hanging fruits there, and the lowest hanging fruit that I can think of there is 10.1.1. Okay, 10.1.2, it's easy to prove, but I don't want to take it for granted. Okay, but let's focus on 10.1.2. So on 10.1.2, looking at the diagram, I want you to think about this theorem. Equal chords subtend equal angles. So it means angle A1 is equal to angle A2 because they are subtended by equal chords because of this theorem. Okay, then I also want you to think about it this way. This is a cyclic quad. Let's identify a cyclic quad here. The cyclic quad is A, B, C, D. That's a cyclic quad. And I want us to produce this so that we get an exterior angle. And we can see that this angle here is equal to this one. So we can say this is x. Okay. And after that, you can also see that if you consider in triangle A, B, C, you can see that angle A2 is equal to 90 degrees minus x. Remember the sum of angles of a triangle. Okay, so this implies that A1 is also equal to 90 degrees minus x. Okay, and in triangle DMC, we can see that angle C2 is equal to 90 degrees minus x. Okay, and the reason there is the sum of angles of a triangle. Okay, now therefore angle C2 is equal to angle A1, which is equal to 90 degrees minus x. This implies that MC is a tangent. Reason is converse of tan chord theorem. Okay, right, so we have grabbed 5 marks from that proof. Okay, 10.1.2, I said, is not a low-hanging fruit, but whenever you see similarity being asked to be proven, please remember that you just need to show that to prove that 2 pair of angles are equal. Then the third one is given, is implied. Okay, so this takes us to the end of all those lowest hanging fruits in this paper 2. Okay, so from these questions, you now have approximately 40 marks that you have grabbed easily, which means that easy marks from the other sections can give up to about 70 out of 150 marks. Remember our part 1 also, we accessed a lot of easy marks. Then if you get 70 out of 150, that is about 45%, which is a pass. That's a level 3 pass. That's not bad. So there is hope, and I want to leave you with an encouragement. Okay, the top 3 tips that I want to leave you with is practice, and more practice. I hope this has helped you, and I wish you all the best. I'm out.